First of all, we welcome you to Azure AI Connect 2025 for this session. And I'm giving your intro on the session that you're going to be giving. You're going to be
Perfect.
talking about data-centric AI with accelerating success with Apache Iceberg data products.
Mhm.
You have been added to the stage. You can start your session.
Perfect.
Do you have any presentation window? I could to the stage.
Yep. I can share it right now.
Okay, you're good to go. Yeah, you can start the session, Andrew.
Awesome. So I can go ahead and start?
Yeah.
Perfect. All right. Welcome, everyone. Thank you so much for joining me today. Thrilled to be here at Azure AI Connect. Really great presentations coming up. So today I'm going to be talking about AI-ready data, the characteristics around that, and how you can achieve that with open source technologies like Apache Iceberg, SQLMesh, Trino. Let's dive into it. So just a little bit about my background. Currently, I'm head of evangelism and education at Topeka, who makes the open source technology SQLMesh. For that, I was at Dremio, doing a very similar role, who works closely with the open source Apache Iceberg. And then before that, I was VP or senior director of data at a bunch of different places. On the side, I'm a graduate professor of data science, statistics, data analytics. And you can catch up with me on LinkedIn, YouTube, any of those places. Happy to continue the conversation there. We've got a big open source Slack community, purely open source. So please feel free to join us on Slack. Really great driven community with lots of expertise who are always happy and willing to help. So I'd recommend if you have questions about anything I'm talking about, jump into the Slack and let's continue the conversation there. All right. So what's the opportunity? We've heard so much about AI, right? Like we can't get away from it. AI is everywhere. We just saw DeepSeek, now Alibaba's in. There's so many AI models coming out. But why? Why are we hearing so much about AI? Well, there's a reason for that. AI is really solving problems right now that we couldn't even imagine it would be able to solve. It's helping us envision new problems. It's helping us envision new ways of working, new productivity methods, more efficiency. Right now, Gartner's reporting that 77% of organizations rank AI as one of their top 5 investments. And I think just a couple days ago, they re-released that report and said it's one of their top 3. So there's a lot of money going into AI right now, and we'll talk a little bit about why. So what is going on as I travel around the world and I meet with different executives? Now, that's a large part of my role is really strategizing and consulting on AI and data strategy. Why are boards and executives pushing for AI? It's really a top-down initiative. If you remember like digital transformation, that was really top-down saying, hey, you guys need to do this. Fine, we'll do it. Where a lot of other data initiatives are bottom-up. It's really us in the trenches saying, hey, please, we need to fix our XYZ. We need to expand our data capabilities. Can we please have some money? Which are bottoms up. So what executives are expecting and why they're pushing these initiatives down is one, innovation. They believe we'll be able to work in new and better ways. Productivity. So 56% of executives believe AI is going to increase productivity by at least 11%. And if you look at the top use cases right now for AI that's actually in production, the number one use case is as a coding assistant across all the Fortune 500 enterprises that were surveyed. Coding assistant is number one. Productivity, workflows, so automating workflows, number two. And then chatbot is number three right now for AI use cases that are actually in production. And of course, this is coming from the top down, so money is clearly one of the top priorities. Everybody that I've talked to believes that AI is going to create revenue opportunities, huge revenue opportunities, whatever that number ends up being. Gartner's estimating 13 trillion. Who really knows? But we believe that it's going to be a huge number. And we've already started to see that with larger revenue. But what is AI? So it's a lot like when Stephen Hawking says the brief history of time. Like, what is time? Like, what are we talking about here? So we're always hearing AI, build AI. But what actually is it? What do we mean when we say AI? Well, I'm old enough to remember when AI really kind of meant deep learning, and that's traditional AI. In some definitions, it includes machine learning, just being able to mimic or doing something that a human would be able to do with minimal human intervention. There's natural language processing. And the big one today is generative AI, being able to create something new based on patterns from the past. So a lot of times when I speak with executives or other data leaders and they say, we're doing AI or we want to do AI, they really mean generative AI a lot of times. But AI isn't just the model. And that tends to be a lot of what we focus on is the AI model. But it's also the data. So a successful AI system is the model and the data. A lot of times with data science or AI teams that I've worked on and led, we chase the model. We're like, what's the best model for this problem, which is important. And then as we do our CI/CD process, we're constantly looking to improve, get better metrics and results. We're like, what's a better model we could do? What's a better model? But the other half of that equation is the data. The data is powering at least the training pipeline and often the inference pipeline. You need to continually improve your data and have the same level of rigor and quality that you do in your AI model. Because the two of them together, the data and the model, are the system together. So you need to have the same level of care and monitoring and improvement in both aspects of your overall system. So talking about the data, I love this quote from Donald Knuth: premature optimization is the root of all evil. Often we're so tempted to just optimize our algorithm, try to optimize the model, try to optimize our prompt. Let's do prompt engineering without first looking at the overall system, the model, and the data, and ensuring that they're both of equal quality first. Get them on equal grounds, have equal rigor in the process of optimizing and maintaining them, and then start optimizing. We often do this on the model before we look at the data. As a great example of this, moving from GPT-1 to GPT-4, what got us from 1 to 4? Well, I would argue that 3.5, 4 was really the turning point for generative AI when most organizations and people decided that, okay, generative AI is usable. I'm reimagining workloads. I really am bought into this. We moved beyond early adopters into a larger segment of the population learning about generative AI. But what got us from 1 to 4? 1 wasn't super helpful. It was impressive for the time, definitely. I mean, if you look at like Google's BART model, GPT-1 was definitely great. And what was it trained on? 4.8 gigabytes of unfiltered data. So just raw data. And what could it do? Not much, but it could do something. I mean, better than before, right? GPT-2, we're growing the data, 40 gigabytes of filtered data. So now we're starting to curate. What can it do? A little bit more. Still not super impressive, not enough where it's really going to get large adoption. GPT-3, we're getting closer. 570 gigabytes, heavily filtered, heavily curated, down from 45 terabytes of raw data. So we're taking the raw data, we're heavily curating it. That gets us to GPT-3. And GPT-4, what are we doing? Human demonstrations and annotations. So labeling, right? The best quality data. Moving from 1 to 4, it wasn't the model that really changed. We weren't inventing some new innovative model. It was the data. The model is really a transformer model. There was no really new model that really took this huge leap from 1 to 4. We expanded the quality and the quantity of the data, and that got us from 1 to 4. And it's true with enterprise AI systems. Improving for selecting a reasonable model that's going to achieve the output and results for the use case, identify the appropriate type of data, and continually improve the amount and quality of that data. That's going to give us, in my opinion and in my experience, huge leaps and bounds in the quality and the use cases of AI that we're able to implement. So, what's the problem? Right? We've been hearing garbage in, garbage out forever. If you've been in data longer than 5 minutes, you know that this is a challenge already, and that every data analyst, data scientist, data engineer is constantly trying to improve the data quality and try to improve their outputs of whatever deliverables they have, whether it's an ML model, an AI model, a dashboard, a report. Data quality has been a challenge for a very long time. It's led to innovations from Bill Inman with the data warehouse, from Ralph Kimball with the data mart. Everybody's constantly trying to improve quality and access. We got the data lake house, which we'll talk a little bit about later. And we know that this is a challenge because CIOs, even as far back as 2022, when they're starting to look at AI, and I'll bet this number is much higher now, 72% of CIOs said that data problems were most likely to jeopardize their AI ML goals. Gartner recently released that they predict by 2026 that 60% of AI projects will fail. And I need to update this number because they just released 2 weeks ago that it's 60% of AI projects will fail specifically because of data quality, not 30%. So in November-ish, they said 30%. Just recently, they said 60% of AI projects are going to be abandoned because they're going to fail to meet their SLAs, specifically because of data quality. So these are AI systems where time and money has been put in. We've pulled in stakeholders, we've pulled in employees, we've tried to productionize them, and then we've pulled the plug. Why? Not the model, or not just the model in any case, data quality. So what's going on with data quality? When I say data quality, I mean accurate, consistent, complete, timely, relevant data. These should sound intuitive and familiar, but there's lots of definitions. This is how I define data quality. The data needs to be right. It needs to be consistent. It needs to be complete. There shouldn't be large missing gaps in your data. It needs to be timely, whatever that cadence is. Sometimes it's real time. Often it's micro batch or batch, whatever it is. There needs to be some kind of set SLA for the cadence, and it needs to be relevant. It needs to be applicable to the specific use case and deliverable for the business need. So what's going on? What is getting in the way of our data quality? Well, these should all seem familiar: data silos. And there can be good reasons to specifically have a data silo, like on purpose, but often data silos are not on purpose and they are on accident, and they're cumbersome. So it can happen through company acquisitions. You buy new units, new companies, they have a new data stack. It takes time and money to fully integrate that data. Sometimes we just leave them alone, and now we don't have a overall view of the organization. We've got different data silos, different data units, different business units can set up their own data stacks and not share that data. There can be governance challenges where it's really hard to determine who should and should not access the data. So then we're very conservative and we don't let anybody access the data. The quality being inconsistent. That is something that kind of came up with data marts, where now suddenly we've got multiple copies of the data, so we don't know which one is the source of truth. I think you can envision that. I've had lots of times where I try to pull the same metric from different systems, and it comes out different. And then folks will ask you, like, where did you pull that from? Like, which system did you pull it from? And they'll say, well, this is the one we follow. And then you go talk to a different business unit, and they'll say, well, this is the one we follow. Not great. Limited data access, insufficient metadata. That's a big one. Insufficient metadata is a big challenge. We need to manage metadata rigorously, because metadata, and we'll look at this in a little bit, is extremely important. And for data integration, for building AI, it makes it so that you really can't discover the data, and it's just, now it becomes a data swamp. It's just useless. We have more data, but less utility in that data, especially now that we have semi-structured and unstructured data, of which AI needs to take advantage of. But if we're not specifically managing the metadata for those unstructured data sources, there's almost no way to use it effectively. So I propose that data products is a great way to solve this problem. When I say data products, I mean there's two things. There's thinking of data as a product, and that's the process of managing it with accountability, and thinking of those who consume the data as your consumers, and with real product management mentality. So treating it as a first-class product, like a real product. There's somebody who owns it. There's somebody who's accountable for it. They understand the downstream implications. They understand the sources making up the data. They understand the SLAs around the data. There's clear communication around it. So that needs to happen. And that's really just the mindset of data as a product, and adding accountability specifically into the data management process. So effective data products, there's a lot of different definitions of data products, and often they come from vendors who define them in ways that just happen to align with their vendor capabilities. In the definitive guide to data mesh from O'Reilly, they do give specific characteristics of data products, or the definitive guide to data mesh, who introduced data products, they do give specific characteristics around data products, but they also do say in several interviews I've seen that they are flexible in the definition. These are the 5 that I work with, and seem to be the industry standards for what really is a data product. It needs to be discoverable. You have to be able to find it. How many times have you tried to do a data project or a project that requires data, like an AI model, ML model, even just a dashboard? You can't even find the data. You type in whatever data you think you need into a search bar, and then 1,000 tables show up. And they all have different information. Not helpful. It needs to be understandable. There should be documentation. There should be clear metadata, trustworthy. How many times have you created some sort of deliverable and nobody uses it because they don't trust the data? They say, oh, this doesn't look right. I'm just going to use my intuition. Not good. It needs to be accessible. Once you find the data, you also need to be able to access it. You need to be able to govern that in an efficient way where the right people can get the right data at the right time for the right projects. So managing that data access has been a challenge. I think that's one thing holding a lot of organizations back from going more federated and more decentralized, where a lot of business units are saying, we really would like to be more decentralized in our data process because we feel like it'll make us more agile, have more control over our data. But at the same time, the central teams who typically handle security and governance are challenged by managing that governance process. There are some ways to work with that, but making data accessible in a reasonable and timely fashion is a challenge that I think data products can solve. It needs to be interoperable. So large organizations have so many different downstream processes. Many of them have different data stacks. How do you make them interoperable? If you create a data product that needs to be consumed by different teams, but they have different data stacks, different systems, how do you make a data product that's going to be able to be consumed by all these systems? So there's a lot of ways to do it. The way that I've seen work the best is making your data product available via API and then controlling who has access to that API. So then you can API in, access the data product through whatever downstream system you need. Super easy, because then it's essentially system agnostic, right? As long as you can consume the API, you can consume that data product. And that seems to work super well. It's scalable. Lots of companies are creating data product marketplaces where they can discover these different data products. They can apply for access to them. And then the API is opened up so that then they can consume them in whatever downstream system that they need to. Super, super helpful. So why Apache Iceberg? Why would Iceberg help with this whole process? So if we think about what characteristics does AI need in its data in order to be successful? Well, there's a few things. One, depending on the model, AI needs access to a lot of data and disparate data. So we talked a little bit about semi-structured data, structured data. A lot of that resides in the data lake. And if you've got data in Postgres, in Redshift, in your data lake, in Microsoft Fabric, in Azure, it's extremely hard to create an AI system that's going to pull effectively from all of those data sources. Super hard. Now you have to manage the cadence. You have to build multiple pipelines. You're probably doing extracts from those systems and landing them somewhere, probably landing them in like your data warehouse. But now we've got multiple copies of the data because we're doing an ETL process, making a copy, landing it somewhere. It just really spreads out your overall data pipeline. And that's the world we've lived in. Why? Because data lakes, while awesome, they present some challenges. So before data lakes, we're really just dealing with data warehouses, data marts, databases. Those are all structured data storage systems, right? Think rows and columns, which is great because those are the deliverables typically that we were sending out and using analytics, dashboards, reports. Those just use structured data. But with cloud data lakes, well, and even Hadoop, we're able to do object storage. So we're able to store more than just structured data. And now we've got so much more data. We've got sensor data. We have the Internet of Things. I was senior director of analytics at an organization that had 70,000 people at one site. When I came in, I was trying to catalog the data. They didn't have a data catalog, which is a issue. But I saw that there was one large table in their data lake that was just categorizing, and not categorizing, it was just storing all of the keycard swipes for every employee for every door that they had to go in and out of. Every time you went in and out of a door, you'd swipe your key card, it would track it. That 70,000 people on site. That's a lot of doors. That's a lot of people. So I asked them, I'm like, why are we storing this? They said, well, it's useful. I go, okay. What are we using it for? They're like, nothing. And that's the case with a lot of the unstructured data that we've been storing. It just lands in the data lake because quote unquote storage is cheap, which is sometimes true, not always. And we think quote unquote data is the new gold, is the new oil. Maybe not. But how are you going to access it? So now we just have just a giant amount of data, which can be good, but the utility is far less than our structured data. There's governance challenges in the data lake. It's not ACID compliant, so now we've got consistency issues with concurrent writes. It's not durable all the time. Governance is a huge challenge. So the data lake, the only way to make use of it, or the easiest way to make use of it for a lot of organizations, was to do an ETL process, extract, transfer, load, into a warehouse. They're like, okay, well, we'll store it here, but anything we need to use, we're going to make a copy of it, structure it, and drop it in our warehouse. Now we've got 2 copies of the data, at least, but that's what we did. Also the format. So if there's a bunch of JSON files sitting inside of the data lake, you don't really know that those are a table. You can't see that. You can't go tell your data analyst, hey, go build a dashboard on top of these JSON files sitting inside of ADLS. It's not going to happen. They need a data engineer to go do an ETL process into a warehouse that structures it. It's going to give it ACID compliance. It's going to give it partitioning. It's going to do a lot of things. It's going to have a set schema. Data lakes typically don't have a schema. So all these things that you need to make data useful for the downstream processes like analytics, AI, not super available on data lakes until 2017. So in 2017, 2016, so Delta Lake rolls out, which is a table format from Databricks, and then very shortly after, Apache Hudi and Apache Iceberg roll out. And what's their goal? Their goal is to make the data on data lakes accessible with the same characteristics that you would have in a data warehouse, but directly on the data lake. So removing that need for an ETL process, making copies of the data, having separate storage systems, which can be super costly in a lot of cases. Just do it directly on the data lake. It gives you some efficiencies. Now it's much faster to query. It can be easier to govern. It's going to have that ACID compliance directly on the data lake. So you can actually trust the data that you're pulling straight from the data lake. And it allows you to really create a central repository for your data. So the vision of Bill Inman's data warehouse was, we've got all these disparate databases everywhere. Let's create a central repository for organizational analytics. This is back in the 80s. And then what happened? We started creating more data warehouses within our organization. Now finance has a data warehouse. Now sales has a data warehouse. So it didn't super solve the problem and achieve the goal of a central repository. Data Lakehouse, which is a data lake with the data warehouse capabilities on top, I believe is fulfilling that vision of the data warehouse. All it has is additional types of data. So now we can store unstructured, semi-structured, and structured data in one place. And with an open table format like Apache Iceberg, which is interoperable across multiple systems to avoid vendor lock-in, now we can access it all from one spot. Well, guess what? That makes a lot of sense for AI. I mean, for organizational analytics as well. It's going to help us break down those data silos. It's going to help us train larger and better models. It's also going to help us do more effective CI/CD processes because we don't have to manage multiple storage locations if we don't want to. We can just do it directly on top of the data lake. Let me show you what that looks like. So let's see if this works. Yep, you can see this. So let me show you the architecture of how Apache Iceberg works. So if we've got all of our data, let's say we've got our JSON files in here. Let's make this a little thinner. So we've got our files sitting in our data lake. There's multiple files. We've got our ingestion, which is landing everything directly in the lake. How are we going to make use of that? How do we know that these files are actually a table? Well, that's the open table format. So let's say these are JSON. and we can organize them as Parquet, which is an open format. So let me show you how you could do this open. So let's say this is an ADLS, data lake. So what do we need to know in order to use these objects and say that they are, in fact, a table? Well, we need to know some information about them. We need to know their metadata. So when I spoke earlier about metadata management as an issue, it's preventing you from doing this. And that's one of the challenges that Iceberg solves, is managing your metadata. So what we do, if we're going to run a query, so let's say that we're using SQL, we're going to query it. We can do that through Apache Trino, which is an open source query engine. For Apache Iceberg. Trino is going to go to a metadata catalog. An example of this, open source. You know, there's proprietary versions of all of these, but let's stick with open source. Like Apache Polaris, there's Project Nessie, but Project Nessie is likely going to be merged into Apache Polaris. The metadata catalog is going to hold all these different snapshots of your data, and we'll talk a little bit about what that is. So when you run that query, Trino hits the catalog. That catalog is going to understand the query, and it's going to determine which manifest list, that's what we call that, it needs to hit. And the manifest list is exactly like it sounds. It has a bunch of different manifests. And the manifests hold the key statistics for the tables. And so it's telling it which of these tables, which of these files, are a table. And because of the way that Apache Iceberg works, it's insanely efficient at query pruning. And so it actually makes it very fast. So this whole process here from metadata catalog down is Apache Iceberg. Because it's an open table format. Nothing's stored in Iceberg. It's a standard for how to organize and query your data. So now you can see that inside your data lake, you can create a way to, through SQL, access all of that data in a super efficient way, just like you would, querying Microsoft Fabric using SQL. Now we're able to do this directly on the data lake. And there's a lot of benefits that this process adds. And you can see we're using Trino, which is an Apache project, open source, for the metadata catalog that Trino's querying. Apache Polaris, open source. The catalog tracks the manifest lists and the manifests, and then we can store this data as Apache Parquet, open source. So everything except the data lake itself, the actual storage system, is open source in this model. And we'll look at another open source technology, which is going to let us organize that data even better. But let's jump back a little bit to Apache Iceberg. So there's a few things that it adds. So that's just the overall general architecture of Apache Iceberg. But what are some of the benefits of it? One, the catalog, depending on which one you use, but Apache Polaris is going to have a Git-inspired design, meaning that it's going to let you do rollbacks to have different versions of your data. And it does that through snapshots. So snapshots enable time travel, which is essentially, what is your data at this point in time? What's your data at this point in time? What is your data at this point in time? which is extremely helpful for AI. If you need to go back and look at, it was trained on this day, what exactly did my data look like on this day? Or it gave this result on this day, which is either good or bad. What data, what exactly was the structure of the data on this day? So it enables that time travel, which is extremely helpful. So the time travel capabilities, querying that historical data, it's so helpful for training AI with reproducing those data sets. Helps with model consistency. So that time travel is very helpful. So just like the architecture that we just looked at, we've got the data layer, right? Where does your data live? It lives inside ADLS, whatever data lake system that you're using. The metadata layer is the manifests, manifest lists, manifest files, right? So it's storing those snapshots. And then we've got the catalog. There's several out there. Some are proprietary, some are open, like Apache Polaris is open source, which points, if we follow the query down, it points to which snapshot do we need. The snapshot pulls the manifest list, which hits the manifest, which goes straight to the data that you need. And because it's columnar, it's very fast. So where can SQLMesh fit into all of this? So inside, I'm going to go back to my beautiful drawing. You can, take a screenshot and show your kids and say you saw the best artist you've ever seen today. So what's SQLMesh and where can that fit in? So SQLMesh is a way to transform your data in a scalable, reproducible way, even for giant companies like Airbnb and smaller companies, startups that are scaling. SQLMesh is open, just like these other open source technologies that we're looking at. And what it does is it allows you to create virtual data models and own them like a data product. So SQLMesh is doing the transformation inside your data lake. And it adds a lot of the characteristics and rigor that you'd get in software engineering. It lets you do rollbacks. You can do true blue-green deployments. You have an owner for your data model. And what I love about it is that it lets you do virtual views through the virtual data environments. Why does that matter? Well, now you can do data modeling without having to make a physical copy of your data, and you can do it in a scalable, reproducible way. So you can make a virtual view of the physical table, but model it, right? Transform it, clean it, but you don't have to physically make a copy or move it. It's just a logical interpretation so that when you're running this query, the query is going to hit your SQLMesh view, right? And then you know that it's well governed because SQLMesh is allowing you to create data contracts on your data. So if you've got an AI that's using this architecture here, let's say that the AI is querying, right, the tables in an Apache Iceberg table format that's being managed by SQLMesh, that's being transformed by SQLMesh, you really want to ensure that all those characteristics, consistency, accuracy, it needs to be discoverable, owned. Well, that's where SQLMesh is coming in to add an additional layer of benefit onto your Apache Iceberg architecture. SQLMesh is going to let you really own those models in a data product fashion. It's going to allow you to implement governance, discoverability, and be able to let you scale it super fast because of that virtual data environment. And so if you want to have Iceberg-based data products, I believe SQLMesh is the best open source way to do that. It allows you to really control the transformation. It gives you insights into your data lineage, tons of benefits. And that's all those benefits are key to a successful AI system. Not just AI, really analytics and ML, but in this case, we're talking AI. Why? Because the risks are so much greater. If an AI system goes off the rails than if a report goes off the rails, because where's the human in the loop? The human in the loop matters in a analytics workflow. Where's the human? We've got a human at the data engineering stage. We've got a human at the data analyst stage who's then creating that report, looking at it, manipulating it with SQL. And then we've got a human at the interpretation, the consumption stage of a business user taking that dashboard or that report and then making a business decision using that information, but also their own context. Lots of humans in the loop in that workflow. With AI, a lot of times we're removing the humans from the loop or pushing them further back. So where's the human? Data engineer, right? Landing the data, creating a model using, in our case, open source SQLMesh to create a data model. And then the AI consumes it. So then we've got an AI engineer building the training and inference pipelines to read the tables created and managed by SQLMesh. But as that AI executes, there's no human in the loop generally. It's just going, and it can go at scale. So the risk is much greater because it's going to start giving results and performing actions without that intervention of a human before it takes those actions. So in the analytics, there's an analyst creating the report and interpreting it and saying, oh, this doesn't look right, or, researching. Then after that, then we've got another layer of scrutiny from the business user. Before any action is taken, they're looking at it, they're interpreting it, then they make a decision based on context and, how much they trust the data. AI, those two pieces don't really exist. We've got an AI system going out, working, producing results, sometimes taking action without human intervention, which is the benefit of AI, right? Because we're looking for efficiency and innovation. There's not humans in the loop in every stage. So if it goes off the rails, huge implications before we can stop and catch it, right? There's actions being taken without a human. And so we want to have those governed, managed, solid, consistent models enabled by Apache Iceberg, which is going to unify everything in the data lake, help us access that data that was previously inaccessible or very difficult to access because it's going to format it as a table, let us read it with SQL. Then we can transform it with SQLMesh, again, transforming it in a reproducible, scalable way using SQL, all open source. And now suddenly we've got unified, governed, accessible data to power whatever we need, but specifically AI. And so this is the architecture that I'm seeing be implemented at small and large companies because we're looking for these benefits. We're looking for accuracy. We're looking for modular code. We're looking to reduce costs, right? Because we've got a bunch of data copies along the way in a traditional data lake, data warehouse, data mart architecture. This is going to really help with that. And I would point out, is this going to solve everything? I've got a lot of these things that we can talk about later. It's not going to solve everything, right? SQLMesh and Apache Iceberg aren't going to solve every need. So there's a couple that I can think of that you would do what I call core and explore. So I believe that this data lakehouse format, doing Apache Iceberg on top of a data lake to centralize your data, should be the core of your architecture. It's going to give you that unified view. So we build our lakehouse, right? ADLS, lakehouse using the Iceberg table format. We can query it with an open engine like Trino. We can build those models and organize them with and maintain them with SQLMesh to have that governance and that rigor. But what if we need a vector database? What if we need a graph database? What if we really need a time series database? I mean, there are specific use cases for those things. Well, do core and explore, right? So the core is going to be your lake house. That's your source of truth. That's your, powering 95% of your use cases. That's a made up statistic, but the vast majority of your use cases, because it can handle both analytics and AI. It can do both. So then you're maintaining the core of your operations, the analytics, and being able to make use of those structured and unstructured data sources all in one storage location, right? Amazing. If we need a vector database, okay, let's branch off and let's get that vector database for a specific use case. If we need a time series database, there's a specific function that we need that only time series database can have for our sensor data. Great, let's branch off and let's get a time series database for that one use case. We're able to control then our enterprise technology landscape by centralizing in our data lake, right? That enables us to prune off a lot of other systems if we need to save costs and efficiency and reduce the burden of duplicate files and models everywhere. And then we know exactly why we have a vector or a graph or a time series database, because they're tied to specific use cases. But it's manageable because our core is unified. And then we branch off as needed. And so the Core and Explorer is a way that I have proposed to many companies and I'm seeing implemented, really starting to move towards that centralized data lakehouse and then only using systems outside that lakehouse for specific use cases. It makes it agile for more federated teams, but also enables governance, which keeps the central governance and security teams super happy. So my key takeaways: AI is growing, right? These colors are bad. I should have changed those colors. I apologize. So AI is growing demand, right? AI is growing everywhere, whether it's an agentic system, which I didn't even get into, Iceberg rules and SQLMesh rules for creating an agentic workflow, which we can look at another time. AI is growing. Everybody's looking at it. Everybody's trying to implement it. Nobody wants to fall behind. You can unify your data with Apache Iceberg right on the data lake. Allows you to reduce duplicate models, duplicate data, reduce costs. It also improves your speed and efficiency with a lot of your queries. It allows you to make use of more of your data because now we can do structured, semi-structured, and soon there's going to be a new data type allowed in Apache Iceberg. I think 2025, that's rolling out with the variant data type. Awesome. It's going to allow us to make use of even more of your data. And then SQLMesh enables scalable, reproducible data products to power your AI. And it's going to allow you to avoid those breaking changes. It's going to allow you to evolve as your data and AI needs evolve. It's going to allow you to create those virtual data models with ownership and be able to implement them with the rigor of a software engineering team. Again, this is open source. It's going to show you that it's stateful. So it lets you know the state of your data, enabling rollbacks, enabling lots of benefits, which is required to power an AI system. So thank you so much. I hope that this was helpful. I'd love to continue the conversation with you. Probably the best way to do that is either on the left, connect with me on LinkedIn, or on the right, connect with me on Slack, and we can talk about open source ways to power AI analytics, specifically Apache Iceberg, SQLMesh, anything open source. Happy to talk with you about. Thank you so much.
Amazing. Thank you so much, Andrew. Very exciting presentation. I will let Praveen say goodbye to you. I just
Costas,
want to say goodbye from my side, and a
Costas,
big thank you for connecting here.
excuse me, Costas, your audio is not good, I think. Okay, all right, the session is done. Thank you very
Awesome.
much for your time, Andrew Matson. Your session on data centric AI accelerating success with Apache Iceberg data products was really insightful. We hope it was informative for the audience as well. Thank you for the session. And for the audience, if you got any questions on Andrew's session, you can ask now. Um, I think no questions are popped up till now on the comments. Okay,
Perfect.
if you have any questions or just want to connect with Andrew, you can reach out to him via his LinkedIn, YouTube, or any social media handle. If you could put up that LinkedIn, it would be more. Okay, I would like to thank you again for the session. We hope to see you more in our future sessions as well. Thank you for
Awesome.
being here in Azure AI Connect 2025. Okay,
All right.
you may
Thank
leave
you.
now. Thank you.
Right. We are back. Azure AI Connect 2025. The time in Greece is 5 p.m. and we are running strong. Our next session is, let me pronounce correctly the names and the session. Okay, we're going to discuss, we're going to see build low latency AI voice agents using real time GPT models. Uh, Voice AI and agents, subsequently, are one of the most interesting themes when it comes to AI and, of course, Azure. We didn't have that many sessions about voice, and this should be one of the most interesting ones as well. I have to say, every session is amazing. Every session is very exciting, and I want to thank you everyone for being with us and supporting our channel. Remember, you can always watch your favorite streams on our YouTube, no matter if you missed the live stream or you want to watch something later. Of course, we're going to create comments in our YouTube section where we will point each session to the exact point in time, so you don't have to search in the video where is your session, where is your favorite session to watch. I can see we have with us Milan and Anu. Maybe I'm pronouncing the name wrong, but they will correct me. So let me add both of them on the stage and let's see. Hello, my friend.
Hey, can you hear me?
Yes, I can hear you. Can you please pronounce your name so I don't make a mistake? Is Anu? Anu?
Yeah, my name is Anuj.
Anuj, Anuj, okay. Uh, I have to say a big thank you, Anuj, for being with us today. We're so grateful to have you in our Azure AI Connect 2025 event. Um, you are one of our top speakers, and we're so grateful to have you with us. Your session is about voice AI agents, a very interesting theme. And if you want me to add your screen on the platform, we will be ready to start.
Okay, great. Let me know when you can see my screen.
And you can put me back in the backstage.
Hey, Milan, of course. No
Hi.
problem.
Yeah, you can
Hi,
put me
hi,
in the
hi.
backstage and just
Yeah,
keep
I will.
Anuj
I
in the
will.
main show.
Yeah.
Can you see my screen?
Not yet.
Let me share the whole screen here. Entire screen. Let me. Okay, let's try this. You should see a PowerPoint.
Yes.
Great.
Great.
All right,
All
you
right,
ready?
everyone. Anuj, build multimodal agents with Azure Communication Services is the title, as I can see. Uh, Post your comments, your questions, and yeah, the stage is yours, my friend.
Okay, wonderful. Are we ready to get started, or do we want to wait for others?
No, you can start. You can
Okay,
start.
fantastic. Hey, everybody. My name's Anuj. I'm a PM on Azure Communication Services. We are a service within Microsoft that enables you to build communications applications. The same kinds of services that we power that we make available to developers are available for our internal customers as well. So you might have heard of capabilities like Microsoft Teams or Dynamics. These are services that are powered by the same core infrastructure that Microsoft makes available to you as developers to build your own applications. And today I want to talk to you about building multimodal agents with Azure Communication Services. We're going to talk about an example of how to build a communications application, as well as some updates to our AI services that have been released this week in public preview. And so I'm excited to get you updated on all of that. Of course, I'm not sure if we have the ability to make it live and engaging, or for folks to jump in with questions. But if that's possible, feel free to have folks jump in and be able to ask questions. I'm just going to do a quick level set. I'm not much of a slides guy, but I do want to give you some background information that would potentially help you understand sort of what the session is about and what the services can do. So Azure Communication Services is an AI-enabled communications platform. You probably heard of some of these services in the market that enable you to build communications applications. And communications applications can range from levels of sophistication. So it could be something as simple as send and receive an SMS, send and receive an email. This can be used for things like marketing and outreach and notifications. Hey, you have a dental appointment tomorrow. Can you still show up? These kind of things that you're probably used to getting. But then we can do a lot more sophisticated things. We can do things like voice and video calling that enable you to do things like a telehealth consult between you and your doctor, or you and your financial advisor. We can even enable you to do asynchronous chat live on a website or on a mobile app that you can do with either a chatbot for customer service scenarios, or even loop in a human to the conversation, all using the secure, powered infrastructure that Microsoft makes available to developers across the multitude of services that we offer. And then we even have like very, very sophisticated scenarios where you have telephony infrastructure that powers contact centers around the world. And this is where you have custom routing rules for routing to the right department, infrastructure to give you super low latency connections. Even when you're driving on the highway with poor quality, we can give you the resiliency and the reliability that you need. And what we're shifting to is the ability to do sort of multimodal agentic communications. And I'll show you an example here shortly, but you can imagine, you're trying to reset your password and you call the 1-800 number for your IT help desk, and somebody's literally walking through the instructions. And that's like the old world way of just like reciting a script. And we think that there's a future world in which you call that 1-800 number, It sends you a link to try to reset your password using a secure, compliant browser and infrastructure. And then it's literally watching you. The agent's watching you on live in real time on the screen, making sure you're following the right steps and guiding you through the process if you need specific help. And that's all automated using AI. And what's powerful about this is you can take the same channels, combine them together, or use one standalone, and build applications that meet your specific needs. And this is a great way to engage your customers, to improve in efficiency of your business processes in ways that don't just involve a standard website or a chatbot. You can engage customers as they see fit on the channels that they're used to. Most people are used to calling a 1-800 number, or most people are used to getting notifications via async messaging services. We enable you to do all those scenarios through the multitude of channels that we offer. And of course, we have these other scenarios like WhatsApp for international scenarios where you might want to engage with users on these sort of alternate channels. Now, what's really cool is that a lot of these services are, a lot of this infrastructure is backed by AI Foundry. So we give you the flexibility and the ability to connect your communications applications directly to AI Foundry using either pro code or low code if you choose with Copilot Studio. And this gives you a lot of stuff under the hood that makes your life as a developer super easy. We give you, of course, the models. You're familiar with Azure OpenAI and some of the things that we're doing in our OpenAI partnership to make the models, the cutting edge models and innovations that are available from our partners in OpenAI available to you. But then there's all these things that developers need and enterprises need to be able to do the things that they want to do to serve their customers or to facilitate these business processes. And whether that's doing RAG against some database or some knowledge base with search, or whether that's ensuring content safety, having observability and monitoring and trust with our responsible AI services, we give you the full suite of capabilities to be able to do that with AI Foundry and connect that to your communications applications. And today I want to talk to you about some of the innovations that we've had some at the model layer and connecting them to communications applications. Of course, you're familiar with your basic GPT models and some of the multimodal capabilities that we have with voice and images and being able to connect your data. But I'm also going to touch on some computer use and responses API stuff that's been launched this week that I want to highlight and sort of get you thinking about the art of the possible for how you might use these in your applications. Like I said, I'm going to jump straight into a demo because I think that's easier for you to see. Let me just pull up Visual Studio Code. Just want to make sure you guys can see Visual Studio Code here. Yes, great. So the first thing I'm going to do is show you my system prompts. We're not trying to be tricky about hiding system prompts. So this is a simple Python application called Recipe Finder. I'm a busy dad, and often this is actually an application of necessity for me. I often will be picking up my kid and need to figure out what to make for dinner. And this is an application that I've hosted on Azure that's available as a public GitHub code repository for you as well, where I just simply want to call the 1-800 number, tell them what kind of ingredients I have, and have it recommend recipes for me based off of my preferences or my cuisine types that I want to delineate for the agent. It's super easy. And then when it's done, it will send me an SMS with the recipe that I prefer. And I can use this as a reference, or I can follow it step by step. Now, the first thing I want to be able to do is start up DevTunnels. So I'm going to run DevTunnel host here. DevTunnels is an Azure service that allows you to connect to your local developer environment from a public endpoint. Why this is important is because we're basically connecting Azure Communication Services and the telephone line that I'm about to call back down to your local machine. And so why this is important is we need a way for your developer environment to interface with our services on the public internet. And of course, you can set up your own sort of network security, but this is a way for me to get that started in a quick demo. And then what I'm going to run is call the application host, which is UV and Unicorn. And what that's going to do is just make my application run locally on this machine. And then I'm going to show you my phone via this window here. And I'm going to call the 1-800 number. And please let me know if you can't hear the phone, but I think you should be able to do it. This is the 1-800 number.
Hi, Anuj. Welcome back. What delicious recipe can I help you find today? Let's get cooking.
Hey, good morning. I have ground beef and broccoli in the fridge. I'm wondering if you can help me find a recipe today.
Good morning, Anuj. Ground beef and broccoli are a great start. Do you have a preference for a particular type of cuisine? Perhaps Asian, Italian, or something else? Also, let me know if you have any dietary preferences or restrictions.
I don't have any restrictions. I'm thinking about making something like an Asian stir fry.
Great choice. Asian stir fry is perfect for ground beef and broccoli. Do you have some common pantry ingredients like soy sauce, garlic, or ginger?
Yeah, I have all
These
those.
would be key for fantastic. Let me find a recipe for an Asian beef and broccoli stir fry for you. One moment. I found a recipe for a Chinese American beef and broccoli stir fry from Serious Eats. Would you like me to send you the link?
Yeah, can you send me a link to my SMS? Okay, great. And then it's using ACS to send me a link to my SMS here locally, and I have Do Not Disturb turned on, so you won't see it, but you will be able to see it here, which is the link to the recipe I wanted. So how does this work? It's actually really, really silly simple. I'm going to show you an architecture diagram right here. Let me know if you can see it. Basically, what we are doing is we are shuffling bytes around. We are literally shuffling bytes of the audio buffer around to the various services and then recognizing events, which is surprisingly fun and easy. So we have our mobile phone here, and this is basically streaming audio to the service. And what this is doing is saying, hey, here's an event that's called incoming call. And this incoming call event is going to tell us, hey, somebody's calling with this phone number at this time. And we'll assign it a call ID. And then we will give you the ability to marshal the media, which is basically another way of saying shuffling the byte array for the media over to OpenAI. This is a real-time WebSocket or WebRTC interface that gives you the ability to literally just send the bytes over, and then OpenAI will respond with bytes about that the model wants to speak back to the telephone line, and we'll send that back to the application. Now, you also notice that I was able to interrupt the agent. And this is really critical for real-time scenarios. Both on, by the way, OpenAI real-time supports both voice as well as text. And so I can interrupt the chatbot or I can interrupt the voice agent live in real time. Why this is super powerful is it makes the conversation way more natural and fluid. If I want to be able to cut off the agent and say, hey, I changed my mind about something, or I have an additional ingredient in this case, it can be notified, hey, I need you to consider some other piece of information or some other intent that I have as an end user. And why this is important in the conversation, in the context of chat or text, is because I can actually, in real time, as the user is typing or as the model is responding, trigger events that would help me maybe gather data that takes a little bit longer than average, and then put that back into the context window so I can respond effectively, or conduct workflows in the background live in real time as it's happening, as opposed to a turn-by-turn conversation where the turn might take a second, the call to call an API may take another couple seconds, and the response might take another couple seconds. And you have sort of this very low fidelity, sort of awkward conversation happening with an agent, even in the context of chat. Some of these APIs in the enterprise, can take 5 to 10 seconds. And so having a real-time interface to make it at least feel like the conversation is flowing more fluidly is really important. And then OpenAI effectively, and Azure OpenAI effectively have both that media layer. Remember, like I said, we're shuffling these bytes. They also have the ability to do signaling. Signaling is just another different way of saying an event or a callback. They give us the ability to do something called functions or tools, function callbacks. And what this enables us to do is be notified or notify the model, something's happened. We want to do something that's interesting. And what this enables us to do in this context with Recipe Finder is either go grab a recipe based off of the cuisine and ingredients. You'll notice that I didn't actually have code in there to specify which cuisine or which ingredients that I had on hand. The model was basically able to massage the conversation transcript data. Even in the context of maybe misspellings or mispronunciations, it'll kind of guess at what I meant and extract out a structured form for me. It'll basically extract out the specific discrete cuisine as a string, and then a list of ingredients as an array of strings. And then I can use that to search on the public internet for the information that I want. In this particular case, I just have a Recipe Finder class that enables me to go back and say, hey, recipe finder.find recipe with the parameters that the OpenAI model provided. And once I get that, it can also say, hey, I also noticed that the user, because I have instructions to ask the user via the system prompt that you see here, ask the user if you want to share a link. This is part of the conversation flow. Since the model knows, hey, I've also asked the user if they want a link, I can also notify the developer on this application via the send SMS API method that I've exposed to OpenAI as well as within my web server. It should be able to go ahead and call that send SMS to say, hey, I found a link with the recipe that we sort of arrived at in our conversation. And then we can grab that recipe and put it into an SMS that we send to the phone number that was the originator of the call. So in this particular case, the originator of the call would be the phone number that I'm calling from. But you could also register a different phone number based off of your specific business rules. Often you might have a healthcare scenario where you have somebody calling on behalf of something, and so you want to be able to send the notification to either the patient or the agent on behalf of the patient. Okay, so let's jump right back into some updates around OpenAI that I want to share with you. Like I said, we are powered or we integrate with OpenAI, and a lot of these pieces of the puzzle that you see in AI Foundry, a lot of those pieces of the puzzle are the models, but they are also some of the underlying layers that we make available to you. Part of the innovation that's available within Foundry is that as a new model gets released, or whether that's an OpenAI model or whether that's a model like DeepSeek, we make those available within Foundry for you to just, within a couple of clicks, deploy them to your environment in a secure, compliant way. And what that enables you to do is get the latest and greatest in the world in both open weights as well as for these proprietary models that are available. And then you can just go to this link right here and get a list of all the new models. And if it's behind sort of a gating process, you can just request access to them. And then I also wanted to talk about some of the new releases that have happened this week in the AI front, because it does relate to sort of how we think about communications applications. In the past, we sort of evolved our thinking around these AI applications and AI models as simply just models that support chatbot scenarios. In fact, if you look at the OpenAI APIs, the API is literally chat.completions.respond, right? Like it's basically like an API that says, hey, here's a new chat message from the user, put that into your context and respond with the next turn of the conversation. And that's great when you have sort of chatbots like ChatGPT or similar services. But in a world where you're developing more agentic workflows and that are completely automated or just rely on a little bit of human response, and you have multimodality in play, whether that's me having a phone call and escalating to an SMS or a chat scenario because I need to go run and pick up my kid, and I just need to transition from a voice experience to chat so I can do it asynchronously, not while I'm driving, but be able to do that in multimodalities that are right for me, or whether that's modalities that are completely orthogonal to the way we think about communications today, being able to literally share my screen so I can show the AI agent, hey, here's what's happening. Can you help me troubleshoot in real time? And then if you can't, escalate to a human who can understand what's actually happening. And so part of the shift is just, instead of thinking about it like a chat send and a chat response, you can just think about the AI agent responding with incremental data. And so this is something called the new Responses API. It's available today in public preview via Azure OpenAI Services and AI Foundry. You can go request access today. But what's really cool about this API is it combines the capabilities that are currently available in sort of the chat-based completions API with the capabilities that have been available via the OpenAI Assistance API, which gives you a way more rich way of gathering data, doing orchestration of various agents in a single API call. And then it also, what's also cool about this Responses API is it includes the additional modalities. So you can actually do additional tools calls or even function callbacks within the Responses API without thinking of it like a turn-by-turn conversation. So an example of this is, hey, I want to go search the internet for a recipe. In my particular case, I actually built the search engine. But now with the Responses API, I don't need to build the search engine. The model will actually go conduct a search via a tool called Web Search, and then go out to the public internet or use its grounding data that it already has available, or even a custom search engine that you've built and call within that enterprise search environment. This is available all within a single call. And you can even have it search for files like S3 files or Amazon or AWS, or sorry, Azure Blob Storage files that you have available, all within that single API call. So it makes it a much cleaner developer experience. The benefit here is you can sort of retrieve data, process information, and take all those actions via the tools and function calling that you want. And then you can integrate them all into single workflows. I think a lot of feedback that we heard from developers with the Assistance API was that this is great that I have an API to orchestrate various other sort of background assistants that might call to my sort of chatbot or my AI agent and sort of orchestrate sort of a mixture of experts with those. But this is a way for you to do that all within a single sort of clean API flow. And then the other thing that I'm really excited about is something that's called the computer use agent, or the computer use agent model. This is a new model that's just been made available in public preview today, this week. You can go to the link in the slide and get access to it. And what this allows you to do is send buffers of the screen that you are literally seeing. That could be on desktop or mobile, and it will figure out next best action against those buttons and widgets and labels that you have on the screen. So it'll do a combination of vision and reasoning, something akin to OCR, but also a semantic understanding of the type of screen that it is, what its intent is, and the workflow that it needs to conduct. And then it will pick apart the specific labels or pixels or like the location of the buttons in the text fields. And it will allow you to basically recommend which button to click. So in the case of a password reset scenario where I'm trying to enable the computer use agent to troubleshoot, why isn't my password reset working? It can see a screenshot of what's happening, look at the specific error in red as a text label on the screen, go do a search against that in a knowledge base somewhere, and then return back and say, hey, you are missing a lowercase letter and a uppercase letter, and you are also missing a number and a special character. And then it can respond via whatever modality I want. It could be a chatbot on the sidecar, or it could be a capability where I'm on a phone line and the voice agent is communicating with me what the actual issue is and recommending a next best action. Then what's really cool is it can do smart task execution. You can actually literally give the agent the ability to conduct the operation with consent and all the security controls that you might want, the ability to conduct the task on behalf of the end user by clicking buttons on the screen. This is something that we're really excited about, but it also comes with a lot of trade-offs in terms of security and intent. And so we encourage you to give us feedback and try to understand how you might use this within your environment. The way this works is just like as I described, you take what's on the screen, you do some semblance of a semantic graph of what's on the screen with what the common capability or intent of the content on the screen is, and then it's sampled by the computer use model. And then you could either execute something locally on your machine, or you could have it execute something that's in a browser already. So you might say, hey, go book me a flight to San Francisco. And it would say, hey, based off of what's on the screen, I'm going to recommend a next best action. Do you want me to go click the submit button? And you could say, no, that's kind of out of my price range. And you could stop the model there. It will do sort of sampled check-ins with you based off of its environment. And so we're really excited about this, and we think it's going to open up a lot of possibility for agentic workflows. The other thing I want to talk to you about is the agent service. A lot of you may heard of this concept of an agent. But what's really cool about the way we expose it in AI Foundry is that we give you full flexibility with all the capabilities that are offered in AI Foundry. But we also make available, of course, the best-in-class models and the best-in-class agent frameworks. So you might have heard of things like semantic kernel or LangChain, which are these orchestration frameworks. In the context of communications, you could pick whatever channel that you want. It could be ACS voice and video calling, PSTN, chat. Pair that with AI Foundry, and then pair that with your very specific model that you want, either custom fine-tuned and trained, or a commodity service that's available, a commodity model that's available in Azure OpenAI. Pair that with your own search engine or your own infrastructure with logic apps or Azure Functions, and sort of collate that all together in one infrastructure. But then you can also use the best-in-class agent frameworks that you want. You could pick something that's an existing agent framework or orchestration framework like LangChain, or you could use the new OpenAI Agents SDK, which was recently relaunched, which allows you to sort of orchestrate both the communications layer and the data that you get from the communications layer with specific tasks that you want the agent to do on behalf of the user, with specific models or with specific data that you might have in your own environment, either within the enterprise or within your security boundary. And what's really cool about this is it gives you the ability to do things in your own way, like the flexibility to pair together both the data layer, the tools and actions that you want with the models that you want, whether that's custom fine-tuned or available from a large foundation lab, with the kind of security, observability, and sort of the network security boundary that you would expect from Azure and Microsoft as a service provider. What's also cool is that you can, within AI Foundry, connect this to your M365 environment to make your SharePoint or Teams data available to it. And this is just a cool benefit that you get by working sort of within the Microsoft ecosystem. The other sort of minor things that I also wanted to call out is the model that I was particularly using in Recipe Finder was something called the real-time API, which we talked about, so how we're shuffling bytes. The other innovation that I wanted to talk to you about was that we've actually made available in a really, really low-cost way the real-time mini model. What this enables you to do is at roughly 25% of the cost, meaning that it's roughly a 75% cost reduction to the full GPT-4o real-time model. You can get roughly the same accuracy, the sort of same audio processing in the voice-to-voice model, and sort of the same latency with much lower costs. And so this enables you to scale up your applications, your communications applications, to many, many more users at much lower cost. And then we also are introducing capabilities around multilingual and real-time translation. And so these are awesome capabilities that I would encourage you to try. A lot of customers come to us and say, hey, can you help me? Maybe I'm a Canadian customer. I've got one person speaking French Canadian, the other person only speaks English or Spanish. Can you help me pair these users together in my B2C conversations? And it's been a challenge in the past, but now these things are, or it's too expensive because you've got to hire a translator. And now these things are available as automated capabilities with some of the innovative models that we're launching. I did want to touch upon one more thing that's available within the communications layer as well as the AI Foundry layer, and this is the responsible AI. And this includes a multitude of topics, not just around the quality of the data and how the model performs. This includes things like privacy and security, reliability and scalability. I would encourage you to really think about how we make these tools available to you and how you want to adopt them, both at the communications layer as well as the AI layer. Building these voice and video and asynchronous messaging agents, it can be challenging to sort of think about these things and implement them from a neutral starting place. And so within Foundry as well as the communications platform, we offer you a multitude of tools to sort of guide you through the process of like, okay, how do I want to think about privacy and security? What kind of data labeling do I want? What kind of tools and processes do I want to enact for incident response? What kind of reliability and high availability do I need in my system to be able to service users for mission critical scenarios with these AI-enabled voice agents? This is all available as a layer of the platform that we make available to you, both with the communications layer and also generally within Azure, but also within Foundry for AI-specific applications. And so I would encourage you to take a look at that. The other thing I want to call out is we make available these services as developer platforms. So whether you choose to use Pro Code, like I've shown you in the demo, or whether that you choose to use low-code solutions like Logic Apps, or whether you choose to use systems like Copilot Studio or Power Automate, these are available within a multitude of different environments, depending on how your enterprise or your business thinks about adopting these services. So I encourage you to go to aka.ms.acs for the communications layer and ai.azure.com for the AI layer and sort of start to play around with these things. We make available within AI Foundry sort of a very low investment experience for developers, where you can just literally just type in ai.azure.com, try out some various chat experiences, completion models, responses models, and get to a point where you can kind of understand what the different models and layers of the Foundry can do. And then within ACS, we make available all these APIs as developer SDKs, as well as sort of Power Automate connectors, to where you can sort of play with, understand how you might build an application or an AI agent using the communications channels to either engage your users or facilitate some of these business processes that you might want to conduct in your business. I'm going to pause there and jump back over to the screen share. That's all I have to share today, but I'm wondering if there's anything that the audience or anybody else wants to share.
Amazing presentation, Anu. Thank you so much for this very detailed explanation. And yeah, I don't see any questions right now. I would like to ask you something.
Sure.
Whether you see a future in a future, I mean a future, in the integration of voice solutions, I mean private branch exchange that supports C protocol integrated with Azure AI Engine and voice. Is this something that you can see a future, or everything's going to be replaced by something new, or is this already legacy? What do you think about it?
Is your question specifically about the integration of SIP within the context of
Yes,
AI?
integration of the SIP protocol and voice over IP.
I don't think SIP goes away.
Okay.
What I do think happens is people realize that the signaling capabilities of SIP are woefully insufficient. So I don't think SIP goes away. I think there's enhancements to the implementation of it that continue to sustain it within specific environments. I think developers. So SIP is just for folks who don't maybe know what SIP is. It's a telephony protocol. It's an interconnect protocol that enables different carriers and different institutions which historically have operated on copper telephone lines to be able to send signals saying, "Hey, can you please transfer this call to this number?" Or "Can you please terminate this call?" Or "Can you please bridge in this other number? My mom also wants to talk to you on this phone line." And it's been around for a really long time. In fact, if you ever call a contact center or an IVR, it's highly likely a lot of the signaling and media for those layers has been implemented on SIP. Now, the question was around what is the role of SIP in the future with this AI-enabled world?
Yeah.
And I don't think that it goes away. I think it just has a lot of limitations, which a lot of the implementation engineers have to run up against. So like an example of this might be, I want to send a signal. Like if I go back to my code base and I say, hey, I want to send a signal with cuisine and ingredients. I might have, 1 or 2 cuisines that I'm interested in and 20 different ingredients. That payload could be, I don't know, 1,000 bytes.
Yeah.
A lot of implementations of SIP, just because the scale at which they operate, restrict the payload size for the payload the data payload that I can put in the SIP operation. So if I say, hey, I want to transfer to this department, but here's the information about the customer that I need to provide, and it could be the customer ID, it could be the specific reason for the call, it could be the reason for the escalation, and it might be some other metadata about the call. And implementation engineers in the telephony world have historically had to work around some of the limitations of the implementation of the SIP within their specific environment. It's not a standard specification in the sense that a lot of the little details are up to the implementation provider. And so I think SIP still sticks around. I think what happens is developers and implementation engineers get creative around these other capabilities that are provided. Now, the other reason why I think SIP sticks around is because a lot of the assumptions around, number one, you generally don't rip and replace existing infrastructure. It takes, as we found out in the Azure business, it takes decades for people to shift off private cloud to public cloud, and that's still an ongoing journey. The existing investments are expensive, and they're multi-year contracts. And so I don't think it goes away. What I do think, I'm noticing is that people want existing SIP infrastructure to be connected to the public cloud because it's got all this AI innovation in it. And in order to do that, you need sort of an extension of SIP, and sort of a middleware application that can ingress SIP communications and egress the media and signaling back and forth between the AI application layer. And so we're seeing lots of customers who are like, hey, I've got an existing contact center. It's a decade old. We're not going to rip and replace it because AI is awesome. But what I do think is going to happen is either the vendors in the contact center space are going to develop some sort of middleware, or there's going to be software providers that are going to say, hey, we work with the existing contact center vendors to deploy a middleware that can go speak to cloud providers and how they do sort of these agentic workflows. And what's really cool about that, it gives the enterprise time to modernize while giving utilizing the same skills that the IT engineers have and the communications engineers have for the existing implementations using SIP. But it gives the developers via that middleware the flexibility to go out and say, hey, I'm not limited by a payload size anymore. I mean, storage is relative. networking is relatively cheap. I can go conduct operations at the full fidelity that the model offers to me and not have to be limited by sort of these one-off asynchronous operations. The other reason why I think SIP sticks around is because within a certain environment, it's ultra low latency. It's designed for speed. So these interconnects are generally pretty fast, whereas you might have been in a situation where you're like, ChatGPT is like taking 10 seconds to respond to your query.
True.
It's not very fun when transferring a call takes 10 seconds before you actually even get a ring. And that can be pretty harrowing. Like you might feel like you're disconnected. And so I think in certain scenarios, latency actually matters a lot. And so I would imagine that for these reasons, that a lot of the reasons that I just articulated, maybe many more, these systems stick around for longer than we expect. I would love for somebody to be like, here's an extension of the protocol, or maybe the standards body back together and says, here's a version for the AI first world. I'm not sure that'll happen, but it's certainly interesting to think about.
Amazing. Thank you so much for that answer. It's like a personal question more because I'm deeply involved into voice over IP integration, and I'm actually looking for a middle ground. And this positioning of yours while answering my question is very interesting. And I kind of know what to do now, what to research. We have a lot of SMBs here in Greece. It's not a lot of the enterprises that are, so many, but there are too many SMBs. They are looking something financially approachable and also being able to integrate. They need the top level premium technology adopted to their small and medium sized businesses.
Yeah.
And that's where we come up, and I believe we have a place to work. And your idea here and your positioning gives me, a new field to explore. Thank you so much for your answer. We have another question from James. How close are we to having a virtual operator within MS Teams phone's auto attendant? Is there something already there?
This is a great idea. I can't say too much about the plans that we have, but I would actually encourage you to reach out to either your Microsoft salesperson or the Microsoft support capability. Most people don't know this, but when you message Microsoft and you say, hey, I have a question about this thing, this capability that exists, or this capability that I want to exist, it actually gets escalated from a support person to an engineer or even a product manager who's very interested in your feedback. So you might feel like it goes into a black hole, but it's actually pretty heavily looked at. And so we want to hear from you. It's like, what does it mean for you to have a virtual operator within Teams? Would you prefer that it's provided to you as a one-stop shop within the Microsoft ecosystem, or would you prefer that it's available to you as an integration as part of an ecosystem where you can pick from the best in breed system vendors, like software vendors that are available in the marketplace, and say, hey, this one offers me a $2 a call or 20 cents a call, and I get unlimited minutes and unlimited messages to resolve the user issue, versus somebody who asked me to pay per minute or per OpenAI call. We want to give you the flexibility, but we are looking for your feedback on whether you want more flexibility or whether you just want a turnkey solution. And I would love to hear from you on whether that's something that's interesting to you. The other thing I want you to think about is within the context of these multimodal AI agents, a lot of the Teams infrastructure is based on a per seat license. And in a future sort of contact center world where you might want an automated voice agent, they're based off of conversation, meaning I have a conversation via phone and then have it resolved within 2 minutes. Or I might have a conversation via phone and then it says, hey, we're going to escalate to an agent. They're going to do some background research, try to resolve your query, and then maybe send you an email saying, hey, we've shipped the thing that was lost in tracking or somewhere. And that's all one conversation, but it could take maybe a full mistake. And what we're trying to understand is like, how many modalities do you want? Do you want modalities that only Teams supports, or do you want modalities like various other messaging providers that maybe we don't support today that are offered through various software vendors? Again, this goes back to the question of like, how much flexibility do you want? And then what kind of resiliency do you expect for those various layers? What kind of observability? What kind of responsible AI capabilities do you want within your business context? There's a lot of, it seems like pretty a simple idea for teams to offer an intelligent auto attendant that's or a voice operator that's totally available to you, included in the system. But there's a lot of capabilities that go into that, and we'd love to hear more about like your specific requirements. Again, most people don't know this, but when you email our support channels or ask for support about an existing capability or a future roadmap item, it does get scrutinized and looked at by a lot of people, and it gets reported against. So I would encourage you to provide feedback to us. It might seem like a large organization, but there's lots of little pockets of interested people who are very interested in the feedback.
Great. Well, I don't see any other question. Thank you so much for your wide explanations and your deep thinking. I have a lot of stuff to reevaluate and rethink. The team and I would like to thank you. We are so grateful that you were able to deliver on Azure AI Connect 2025. Hopefully, we will see you in another event of ours. I wish you to have a great day, afternoon, or evening. Where are you calling from, by the way? Are you in the US?
Yeah, I'm in San Francisco, so I'm calling from.
So kind of morning there, something like that, or evening. Okay. Great. Thank you so much, Anu. We will stay connected. And we have our next speaker already on our queue. So I will play a little video, like a small break, and we are ready to welcome Elon. Let me play that video for you while we're saying goodbye to Anu. Goodbye, my friend.
Wonderful. That was fun. Thanks, guys.
Later. Great one. Bye-bye. Right. We are back, Azure AI Connect 2025, and we are coming to our last session for our second stream or room 2. While we had a very interesting presentation, we have with us Elon. I think, Elon, you are in the wrong room, and I will give you the link to go to the previous to the correct room. If you don't mind, let me do that for you. You're supposed to be in room 2. Maybe I gave you the wrong link, or I sent it to you over LinkedIn, but you probably have not seen that. That's not a problem. Let me share that with you. Is he gone? I think he's gone. Okay, here is Elon. Elon, I'm giving you the correct link in the private chat. Please check it out. And this is the room that you're going to present. And We wait for our final speaker. Let me see if we were able to bring Skylar with us. He was interested in giving a session, and I believe we are waiting for, let me see, Pavitra. Pavitra, yes, we are waiting for Pavitra, but I think Pavitra has responded that everything is okay and she will be able to deliver. Let me have a quick look. I think she will be able to deliver. Also, our operator is with us, Maria. Hello, Maria. Okay, let's play our video. Grab a drink, a water, or something, and I believe Pavitra will be very soon with us.
Good afternoon, everyone. Welcome to the last session of Azure AI Connect. Now we have a very interesting topic from our next speaker on enhancing document processing with Azure OpenAI and Azure Search. Pavitra, the stage is yours.
Hi, Maria. Thank you for introducing me. Hello, everyone. Thank you for joining today's session on document intelligence. Today, we are going to explore how AI powered search is transforming the way business retrieve the information. Think about how much time we spend searching for documents like contracts, invoices, and other reports, etc. Right? So that is where document intelligence comes into picture. Our traditional search, it relies solely on the keywords. If you give the keyword, it will match the exact keyword and deliver you the results. But what if you have forgotten the keyword and you know only the meaning of that? That is where our AI powered search comes into picture. With the AI cognitive search and Azure OpenAI, we can move beyond simple keyword search to more intelligent and context-aware search, which also gives you conversational experience. With that, let's understand the architecture of Azure Search. So, according to me, Azure Search is the engine for the AI retrieval. So imagine you have thousands of legal contracts. Instead of manually searching the contract each one by one, Azure can scan that index and it will create the database and it will give you answers based on the meaning and intent. So Azure Search has three main components. The first one is indexing. Say you have a document. What Azure Search will do, it will fetch your document and it will create the indexes. And the second step is querying. It will search based on either word or the meaning you are providing. And the third important step is ranking. The querying gives you the results, but this ranking, it will prioritize the most relevant results for the exact input which you are requiring. Let's see the architecture of how this indexing works. Say you have a source data, for example, leave policy document. So it will be mostly a 40 to 50 page of documents, right? So when you upload that data to Azure Search, it will first open that data and create the data into chunks, that is smaller pieces of document. And once the chunks are created, it will convert that chunks to vectors, that is embeddings. So we are going to combine Azure Search and Azure OpenAI. So we all know that Azure OpenAI uses the LLM models. That means large language models. So that models understands only embedding. So that is the reason it converts the data into vectors. So once that vectors are converted, it will be stored in the embedding store. That is called vector index. And once these embeddings and vectors are created, what Azure Search will do is it will create a link between your chunks and your database so that the search, whenever you search via Azure, it will give you results more faster. So we have shown what is indexing, and then comes our search. So we have many types of search under Azure. We are going to see the four main search. The first is our usual search, that is keyword based search. So if we give any input, it will check for the exact text and it will give you the output. And the second one is vector based search. This vector based search, it will not only consider your word, it will understand the meaning of the input you are giving and deliver results based on that. So for example, if you are searching and even if your query doesn't contain the exact word you need, AI can still find the most relevant result based on the embedding. And the third one is semantic search. So the vector search understands the meaning, but the semantic search understands the user's intention behind the query and responds based on that. And the fourth one is hybrid search. This is nothing but combination of these three searches: keyword based, vector, and semantic search. And there comes our Azure OpenAI, the brain of document intelligence. So it does the most common things. It will understand your query and summarize the data for its understanding and extract the output and generate based on the need of the user. So we know we are going to use Azure OpenAI. But do we know what model we need to use? There are many models like GPT 3.5, 4, and now came 4.5. Choosing the right model plays a key role in your document intelligence or any other intelligence services. So here I have listed a small comparison of how the latest GPT models work. So for example, if you go for GPT 3.5, it will be fast and it will be a little cost effective, but it will create hallucinations. It has old data and it will create hallucination. Sometimes it won't understand the user's meaning. And there comes the GPT-4. It will understand better and give a better response, but the responses are slower. And if you go to GPT 4.0, it has some pros and cons. And now came the GPT 4.5, which is currently in preview. If you see the pros of GPT 4.5, it is highly optimized and the hallucinations has been minimized, but it requires higher processing. So choosing the right model is based on the requirement you have. And the last but not the least, but the main thing is prompt engineering. So here I have tried to divide the prompt engineering into 6 steps. The first step is objective. So in Azure, they call it as zero shot. You need to define what you expect from AI. And the second step is structuring. You need to format, you need to give clear instructions for AI, like how it should work and what are the things you should consider. And the third step is context. You need to give the current context for AI to get better results. And the fourth main point is examples, that is called in the Azure world as few shot prompting. You need to give some sample inputs and sample responses for AI to match your exact requirements. And the fifth step is optimizing and refining. So you have done the first 4 steps of prompting. What you can do is just check with AI how it answers, and based on the answers and the input which you need, just test and tweak for accuracy. So it will give you better results. And the last one is validation and iterating. So it is same as the fifth step. Just review your responses and update the prompt based on the response you need. So with this, we can go for the live demo. So we are going to use Azure Search and Azure OpenAI for document intelligence. So as we all know, these two are the services provided by Azure AI. So you need to log into your Azure with a pay-as-you-go account, and you need to go under Azure AI services. When you go to the Azure AI Services Hub, you will have a list of n number of services offered by Azure, AI services offered by Azure. In that, we are going to use these two services, which is Azure OpenAI and Azure Search. So this is exactly like creating any other services in Azure. I have already created one Azure Search, Azure OpenAI. Once you have created a service, so I will just show how to create one. So here you have to select your resource group which you are going to use and your region, and give a name for your service, and choose the pricing tier. So currently I am giving all networks for our testing purpose, and tags, and review your details and create the resource. Once this resource is being created, okay, let it create. It will take a minute or two to create the resource. Let us wait for that. Yeah, our OpenAI resource has been created. Once you have created your OpenAI resource, you will be given an option to go to the Azure AI Foundry. So when you click this, it will open the default Azure AI Foundry where you can work on play around your OpenAI services. If you see in the left now, you will see the home and you will see a model catalog in which you will have the predefined LLM models which is already trained by which has been provided by Azure. You can just use that model for your document intelligence. Here I'm going to create two models. One is for our chat, that is GPT, and the second one is a embedding model because we need to create embeddings in our for our Azure search. So it is very simple steps. You can just choose whichever model you want based on your requirement and select that model. And just click deploy. You can see the details here, and you will have one more option like customize. So in that, you can define your model how many tokens it can return per minute. So currently we have 100k tokens. I think this is enough for our testing. Let us create the model. Our GPT-4 model has been created and we need to create the second embedding model. If you see in the model catalog of Azure OpenAI, you will have n number of embedding models, text embedding 3 large, 3 small, and some other. So we are going to work on today. Today we are going to work on embedding 3 large. If you see under the model deployments, we have two models. One is GPT-4 and the second one is text embedding 3 large. So now we have created the model. Let's come back to OpenAI later. So now we will see how to configure the Azure search. So go to home and go to your Azure AI services. In that you will find Azure AI Search. It is also like creating any other Azure resource. So choose your resource group name and give your service name. Leave policy search service. And here you will be asked to choose your pricing tier. You will have different types of pricing tiers starting from free to large. We are going to choose standard because free is not supported for the integration with OpenAI. And next, so you will see how much units and estimates you will get and the partitions. The networking currently we are keeping it as public tags and we are going to create our search resource. This estimated cost is one, if it is here mentioned as 20,000 rupees, but it is purely based on your token usage. We are initializing the deployment. Our search resource has been created. If you open the search service, you will see the first thing will open this overview. So when you come to the search management bar, you will find many options like indexes, data sources, skill sets, and semantic rankers, knowledge centers, etc. Initially, what search done was we need to import the data and we need to configure these indexes, skill sets, etc. manually. Now we have one option called import and vectorize data. So what this option, what it will do is we just need to connect our data and choose the model. It will automatically create your indexes, skill sets, semantics, vectors, etc. at a single click. So now we are going to import and vectorize our data. First thing, as we saw in our presentation, is connecting our data. So we need our data somewhere, our document somewhere. So these are some of the options provided by Azure: blob storage, lake storage, or any other databases. Currently, we are doing document intelligence, so we are going for Azure blob storage. Today we are going to see a leave policy document. So I have my leave policy already uploaded in a blob container. We are going to choose that container. Choose your folders and just go to next step. It will validate your data source and it will proceed to the next step. Let's wait for some more time. Yeah. So once your data has been connected, you will be asked to vectorize your text. In this, we have created a text embedding model in our Azure OpenAI. So we are just going to choose that. Choose your search service, OpenAI service, and choose your embedding model. So we have deployed a text embedding model. And authentication type is based on their requirement. Currently, I'm going for API key. And you need to acknowledge it. Just proceed next. And in the third page, you will be asked to, if, for example, if your document contains any images, we can vectorize that also. Currently we don't have any images, so we are just skipping this. If you see in the fourth page, advanced settings, you will have the first option is, do you want to enable semantic ranker? That is the thing we saw in the semantic search. We are enabling the semantic ranker. And the second option is indexing. So we can schedule the indexing here. For example, we are going to update the document regularly. We need to create the index again, right? So based on the requirement, you can schedule the indexing. So currently I'm keeping it for once. We can even trigger this indexing manually also once this setup is done. I'm clicking next. So here I will be asked to give my vector name. I'm giving my vector name and I'm just reviewing my configurations. I'm clicking create. So if you see here, it will be creating index, skill set, indexes automatically. So once you created that, we can just, now we have created and indexed the data, we can just search that. So here you will be provided with a screen to search the data, search the details in your data. If you see the total storage is 0 byte, I think it is currently indexing. What we are going to do is we are going back, and if you will be finding option as indexes. So here we can check the index. So now the vector index is 4.38 KB. If we open this, here if you see, I have uploaded one document, but my document has been converted into chunks as 40 subdocuments, and it has been vectorized. I will try opening my document. So this is my blob storage and my blob container. Here is where we have the leave policy document. Let us open the document and see what data has been present in that. So here if you see, I have the details related to my company policies and leave policies at a workspace. For example, we will try to see one of the options in business ethics or any other things. Let's go back to our search page. Here we will try searching ethics. If you see, we have got the result with after searching in 40 documents, and it will give you the key, the text from the document, the exact text from the document, and the some other highlight points, and it will give you the scores. This is where we have learned the semantic search. It will find the number of results and it will create a score for each result, and based on the score it will give you the perfect results. Now we have the search result, but it is not user friendly, right? That is where we are combining this with Azure OpenAI. Let's see how to combine this with OpenAI. Now we are coming back to our Azure AI Foundry portal. Here, if you see in the left navigation, you will see an option called chat. So this is the chat playground where you can play around with your search data and OpenAI data. Here you will have some options like setup, like you will have the deployment model which you have chosen, and the instructions, that is our prompt. And the another section is adding your data. So here first I will start with a query. I haven't configured any prompt and I haven't added any data source. I will try a query. The same leave policy. If you search for that, since we haven't linked any data or given any prompt, it will perform as the default OpenAI model, like our ChatGPT. It will give a common answer based for a leave policy. So now I will ask, how many sick leave per year? So here it is giving a common answer, right? The number of, okay, let's let it complete. Since we haven't configured any data source, it is giving us a common answer. Let us try after configuring our data source. If you see in the left now, you will have an option to add your data source. Here, we are going to select our Azure AI Search. And the subscription, you will be asked to select your AI Search service. If you see, this is the service which we have created, leave policy. And once we select the service, the search index under that service, we can create n number of search indexes under a single search service. Now we have only one. We will choose that and just click next. So here you will have the type whether you want to search semantic or keyword. We are choosing semantic, and we have already created the semantic configuration. We are just choosing that. And here for the authentication type, we are giving API key. It will validate, and once it is done, we can just save and close. That's it. Your data has been linked. And if you see, you will see an option. You will have a new query window. Now if you ask the leave policy, how many sick leaves per year? So here if you see, Ethan provides 3 sick leaves per year. It is, since we have linked the data to our OpenAI, it is currently fetching only the data, not the open source. So if you see down, it will give you reference also where you can see in which page it is checking that. So it has given us a citation in which there is in the company policy document, we have the sick leave detail. So currently we don't have the prompt configured, right? So it is just providing the exact data. It's understanding the user's meaning, but it is just providing the exact data from the document. So this is where our prompt configuration comes into picture. So here Azure has provided additional support for us to even generate the prompt. Here you will have option to generate the prompt. What we are going to do is we are just going to provide an overview of that, and it will create prompt for you. So we are going to give an employee handbook assistant that helps user to get the details in a friendly manner. So just click send. Here Azure will create the prompt for you, generate the prompt for you. It is being generated. So now our prompt has been configured. Let me expand this and show to you. If you see the prompt created by this, so these are the 6 steps we have been talking about. This is the initial prompt, that is we are telling the AI what it has to do, and we are giving the detailed step like understand the user query and extract the relevant information, answer in a friendly tone, offer additional help, handle edge cases, and we are giving in which format we need the output. And we are giving some examples like example 1 user query and what responses assistant can give, and some additional notes we need. So now let us try the same question. Okay, it is not giving the correct answer. Let us try asking the question in a different way. So it is giving me it provides sick leaves per year, not on a monthly basis. So let us try some other questions. Like let us just check harassment. I'm not giving the correct spelling. Let us see how the AI works. It's search on my document and giving the details. So if I search some other content which is not related to my document, so initially it has answered before configuring the data and the prompt. Let's see how it works now. Let us say the latest Indian movie, some random text. It will just say the requested information is not found in the retrieved data. We will try any other topic. So if you configure the data source and prompt for your OpenAI, it will just answer. It will base only for your document. So that is where it will act as an agent for your document. You can configure n number of data source you want and within your organization or any other details you need, like HR policies, leave policy documents, contracts, etc. And Azure AI also provides you endpoints for us to develop it customly. So if you see here in the top right, when you click the name, it will give you the endpoint of OpenAI and the keys, so that we can configure this in our custom system and we can build a custom solution on top of that. So key takeaways of today's session is traditional search is outdated and AI powered search is the future. And we have seen about Azure Search and how it retrieves the best data even if the keywords doesn't match. And the third thing is Azure OpenAI, which generates intelligent summaries and insights for user. And not the least, the prompt engineering, which is the key to get the best out of AI. So that's it from my session. Thank you, Azure AI Connect, for having me in this session.
Thank you very much, Pavitra. That was one of the final sessions of Azure AI Connect. Thank you again to everyone who attended our event over these past days. Thank you very much.
So that was it, my friends. Azure AI Connect, at least stream one or room one, has come to an end. And with this end, we are starting to close up Azure AI Connect 2025. It has been an amazing 5 days event series with exciting sessions. We learned a lot. We've seen how the future of AI will be, what is in the future also for cloud development and tech enthusiasts all around the world. We had with us MVPs, IT professionals, Microsoft employees and experts. And I'm so grateful for everyone either attending, speaking, or contributing as a moderator and organizer within this event. Big thanks to Azure developer community Tamil Nadu. Guys, you were amazing. Your help was a lifesaver, to say at least. This event wouldn't be possible without your help. And it was great knowing each and every one of you. Big thanks to Maria. Maria Anastasia Mustaka was also has been also an organizer and moderator. Thank you so much, Maria, for being here to help us and stay and support our channel and this event as well. Hopefully, this event will be a yearly thing, a yearly event series. Maybe we will condense it a little bit. 5 days were too much, to tell you the truth. I was very excited to see almost 60 speakers were able to submit. Of course, we couldn't accept every session. We wish we could, but it was physically impossible to have every session delivered through our streams. Anyway, whether you are attending live or this is one of the pre-recorded sessions that you're watching, we have come to an end. Thank you so much, everyone. We wish you a good day, good evening, and good night, wherever you are. You are so long. Stay connected through our channels, ai-athens.gr, and you will find the schedule so you can watch your favorite streams in your own time. Have a great one. Thank you so much. Bye bye.